Looking at the second lesson of Unit 8, we're going to be talking about arithmetic sequences and partial sums. So an arithmetic sequence, if kind of in layman's terms, is if you're adding or subtracting by the same number. So if you take your second term and subtract your first term, it would equal if your third term subtracted your second term, and so on and so forth. We call this number the common difference. So that's kind of like the vocab or the wordage that we'll use often with arithmetic sums. So if I took the sequence 7, 11, 15, 19, again, I would say, all right, what's my common difference? This is a difference of 4. This is a difference of 4. This is a difference of 4. So I could, fairly comfortably say that this is a common difference of 4. Now, if I had to come up with an equation, I would say, all right, I know that it's multiples of 4, so it's going to be 4n. And now I just got to think about how do I get my first term. If I assume n equals 1, 4 times 1 is 4, plus 3 gives me 7. And again, you can go through and check like your work as you move through that. Different type of example. If you get a sequence that's like 2, -3, -8. This time, again, I'm decreasing. This is -5, -5, -5. So I think that I'm going to have some type of multiple of -5. And then if I think about what my old term or my first term is 2. So if I start at n equals 1, I would say 7 subtract 5n. Starting at 7, subtracting 5 gives me 2, which is my first term. So this last one, if I look at this one, I'll say, all right, this one's a little bit different. Let's say that my first term is my first term is 1. My second term is 5/4. My third term is 3/2. My fourth term is 7/4. And I'm going all the way through. So again, how do I determine this? I say, all right, well, this is actually, if I take 5/4, subtract 1, that gives me a difference of 1/4. If I take 3/2, 3/2 is the same thing as 6/4. So 6/4 minus 5/4, it's a difference of 1/4. So my common difference is 1/4. And then how I can try to look at it, again, because I have to get my first term as 1. So if I think about I have n plus 3 and then 1/4, I would write it as dividing by 4. And that is, again, when n equals 1. So there is an equation to help you find the nth term of a sequence. And so kind of our basic formula is a sub n equals d, which is my common distance or common difference, dn plus c. So c equals again, I take my first term, subtracting my common difference. Find a formula for the nth term of the arithmetic sequence whose common difference is 3 and first term is 2. So I would say, all right, well, if my c for my equation right here, this is like subset of my equation, is a1 minus d, 2 minus 3 is -1. So I would say that my common difference is 3n, so I would say that my equation is 3n, and then because my c was -1, I'm going to say 3n minus 1. And this will get me the formula that I need. Writing the terms of an arithmetic sequence. So the fourth term of an arithmetic sequence, so a sub 4 equals 20. The 13th term is 65. Write the first several terms. So if I think about this, I know that they're related. I could say, all right, I have a sub 13 is equal to a sub 4 plus 9d. A sub 4 is 20, and a 13 is 65. So I have 65 equals 20 plus 9 times d. If I simplify this, I get 45 equals 9 times d, divide by 9. Therefore, d, my common difference, is 5. So I could, if I worked backwards, so let's say a1, 2, 3, 4, 5, 6. I knew that my fourth term was 20, which makes this one 15, 10, 5. And if I wanted to go the other way, I would have to add it. Another idea that we deal with in sequences and series is to use a recursive formula. So recursive means the previous term. So what we mean by that is that if I want to find the fifth term, I need to know the fourth term. If I want to know the 100th term, I need to know the 99th term. So if I said find the seventh term of the arithmetic sequence whose first two terms, so a sub 1 is 2 and a sub 2 is 9, and we want to find the seventh term. It tells us that our common difference, because again, a2 minus a1, 9 minus 2 is 7. So I know that my common difference is 7. And then to find my the second part of my equation, I'm going to use that bottom part where I take my first term minus my common difference. And so my first term is 2. My common difference is 7, which means that my second number of my arithmetic equation is negative 5. So I would say, all right, if I wanted to write this out, I would say I could find 7n minus 5, and then I would just plug in a 7 every time I saw an n to get an answer of 44. The second part of this assignment is about finding the sum of finite arithmetic sequences. So another way we could kind of write this is, again, a1 plus an on the top, and then you could say, and then multiplied by n, and then divided by 2. Again, this is the same thing right there. So for example, let's say you need to find the sum of the following numbers: 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. You would say, all right, if I went to number these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 terms. So if I'm using this formula, my n equals 10. My first term is 1. My 10th term is 19. So I'm going to plug those in and say 1 plus 19 times 10 divided by 2. And that's going to give me 100 that's going to give me 20 times 10 is 200 divided by 2 is 100. If you had to find the sum of integers from 1 to 100, again, it would be very similar. This time your n is going to be 100. So your first term is going to be 1, your last term is going to be 100. And then you are going to, again, have 100 divided by 2. So 101 times 50 equals 5,050. You can also find partial sums of arithmetic sequence. So if I said I will add this sequence, so we'll call this the partial sum. And let's say we had the sequence 5, 16, 27, 38, 49. And I want to find the 150th partial sum. Well, we kind of got to figure out our sequence first. So I know my first term. My first term is A1, which is 5. And so to find my common difference, I'm going to say, all right, 16 minus 5 is 11. 27 minus 16 is 11. So I can say that my common difference is 11. And now I take that second part of my equation to find my first term. This is how I find my first term. I say my first term, or excuse me, not my first term, but what I complete my equation with so that it works with my first term is A1 minus my difference, which is 11. My first term was 5. So 5 minus 11 is negative 6. So our equation to find whatever term is 11n minus 6. Now I can just plug it in to my equation to find my 150th term. And that equals 1,644. Now, because of this and because of this, I should be able to have everything that I need to solve my problem. The sum of the first 150 terms is 150 divided by 2. And then my first term was 5. My last term was 1,644. And when you simplify that, you get 123,675. Last problem that we're going to do, it's an application problem. An auditorium has 20 rows of seats. There are 20 seats in the first row. Here, so it kind of looks something like this. A little trapezoid shape. So let's say that the first row right here has 20. 21 seats in the second row. 22 seats in the third row. And you're going to continue on again until you get to the very end. How many seats are there in all 20 rows? So how many seats total are there in this whole thing? So we can form an arithmetic sequence because our common difference is 1. It's increasing by 1 each time. My first row I know has 20. So if I'm looking to finish my formula, I'm going to say, all right, 20 minus 1. So I'm going to start with 19. So my formula is going to be a sub n plus 19. Again, n is increasing by 1. If we need to find the 20th row, we'll plug it in. 20 plus 19, which is going to give us 39. So we have this, and we have our first term. So we should be able to continue with our formula. The sum of all the seats. How many seats are there total? 20. My first term plus my last term divided by 2. And when you simplify that, 10 times 59 equals 590 seats.